For centuries after the dawn of civilization, man regarded our Earth as the center of the universe. Increased knowledge has led us to realize that the Earth is only one of several similar bodies that are all dominated by the sun. With clock-like regularity, the Earth, along with the other planets, revolves about the sun. Although we have become accustomed to having things come and go, nevertheless we somehow cling to the notion that there's no beginning and will have no end. The sun was without planets, and as it traveled through space, it came. As the two stars approached each other, their mutual gravitation curved their paths, increased their speed, and produced tidal bulges on their surfaces. Matter was ejected from our sun and given an angular motion by the other star as it passed onwards. The ejected material circulated about the sun. In time, larger pieces swept up smaller particles and grew in size to form the planets. Held by the gravity of the sun, they move in nearly circular paths. Here are the four largest planets: Neptune, Uranus, Saturn, and Jupiter. Jupiter, the fastest moving of these four planets, makes a revolution around the sun in about 12 years. As we move closer, the terrestrial planets come into view. We now see Saturn, Jupiter, Mars, the Earth, Venus, and Mercury. All these planets can be seen by the unaided eye. Note that the greater the distance of a planet from the sun, the longer is the period of revolution. During this scene, you are watching the motion of these planets from the year 1935 to 1950. Here is a closer view of the Earth, Venus, and Mercury. Let us disregard Mercury and determine the motion of Venus in relation to the Earth. The arrows represent the lines of vision from the Earth to the sun and from the Earth to Venus. Since Venus moves inside the Earth's orbit, the two lines of vision always form an acute angle, and from the Earth, Venus appears to move back and forth in relation to the sun. On successive evenings, we watch the motion of Venus in the western sky. For 9½ months, it is an evening star. We follow its motion below the horizon, though Venus would now be visible as a morning star in the eastern sky. Through a telescope, Venus exhibits all the phases of the moon. The bright portion indicates the part illuminated by the sun, while the rest of the planet is on the dark side or away from the sun. The exterior planets present quite a different view. Mars, the outside planet, is best observed at this opposition. 2 years later, we will have another good opposition. At the next two oppositions, the Earth and Mars will be further apart. The apparent motion of Mars, as seen from the Earth, is the result of two motions, Mars and the Earth's. Note how the arrow joining the Earth to Mars changes direction before and after opposition. Nightly, Mars moves among the stars, periodically becoming stationary, and then slowly reversing. At opposition, Mars appears to travel fastest westward. Passing opposition, it slows down, again is stationary, and then slowly resumes its original eastward motion. Through a telescope, Mars is seen to rotate once in 24½ hours. It has seasons like the Earth, but they are twice as long as ours. The white polar cap is low-lying mist and frost formed during winter. This disappears during spring. The dark bands then become more intense, suggesting growth of vegetation. Beyond Mars is the largest planet, Jupiter. Galileo, with his crude telescope, discovered 4 moons about the size of our own moon, revolving about Jupiter. As they revolve, crossing in front and passing behind the disk, disappearing into Jupiter's shadow to reappear again, they constitute a celestial clock. 5 additional moons were discovered around the beginning of the 20th century. Further out is Saturn, the most remote planet known in ancient times. Saturn also has a large family of moons. But more spectacular are the disk-like rings that surround Saturn's equator. As the position of the planet changes in its orbit, we see these rings edgewise every 15 years. We have now observed Saturn as it looks from the Earth during its 30-year period of revolution about the Sun. During the last century, hundreds of smaller bodies, planetoids, have been discovered revolving about the Sun in the region between Mars and Jupiter. Of particular importance in measuring the scale of the solar system are the planetoids that come within the orbit of Mars. Here is one that remains beyond the orbit of the Earth. It is an object but a few miles in diameter and visible only through a telescope. Another recently discovered planetoid actually loops Earth and Venus. Even at its closest approach to the Earth, it is still much further away than our moon. The orbits of the planetoids are usually more elongated than those of planets. Of all the members of the solar family, the awesome comets seem the most unruly. Halley's Comet passes inside the orbit of Mercury as it swings past the Sun. Then it moves out beyond Neptune, completing its orbit in 75 years. Halley's Comet last visited the Sun in 1910. Note that the tail of the comet is repelled by the Sun. In May of that year, this tail, composed of tiny particles, actually swept the Earth without noticeable effect. There are other comets that travel further out than the orbit of Neptune. We naturally wonder if there are other and more distant planets. In 1930, Pluto was discovered. This planet is rather small in comparison to its neighbor, Neptune. While the planets, planetoids, and comets are moving about the Sun, the entire system itself is moving in space among the stars in the direction of the constellation Hercules. One may ask many questions. Are there other solar systems like our own, somewhere far out in space? May there be planets similar to our Earth, with life such as we know abounding upon them? And finally, what will be the ultimate fate of this Earth upon which we live? And what will eventually become of the entire solar family?